step. That is fantastic. Have I told you that you don't have to do that first?
Yes.
If you wanted to, you could undo multiplying by doing what? You could divide, and then the 4 would cancel out, but then you'd have to divide here as well. Division property of equality. It would work out. It would work out. But most of you, I suppose, distributed, which is a great idea. So you get 12D minus 4. Does that look right?
Yeah.
And then you have an issue. You have the variable in multiple spots. So in order to solve for that variable, you're going to have to get it down to one variable only that you can isolate and get by itself. Yeah, Carmen?
I just divided 12D by 12D and got D.
Well, if you divided 12D by 12D, you get 1.
Which is D.
But a D.
1D is
No, it's just 1. You know what I mean? Because D's a
divide each
number.
other out.
So I think that's interesting that you bring that up. Don't write this down, but I like what she's bringing up here. You could decide to divide by 12D, which is not recommended, but it's going to show something kind of cool. Remember that if you divide and there's addition or subtraction, you got to remember to distribute the division. So you divide this by 12D and what else? This by 12D. And what's kind of curious is she does, if she did it to its conclusion like this, she would get, I think that's 1/3. Yeah. She does now only have 1D. So it did kind of help in a way, right? Now you just got this to get by itself. Kind of weird though, because it's in the numerator, isn't it? Or I'm sorry, denominator. There we go. So it could be helpful, but that's not how we're going to go about this. Instead, Dharma, let's not divide 12D. Let's subtract 12D. And with addition and subtraction, you just have to do it one time on each side. But what's funny? What happens?
It cancels out.
0, right? What are you left with?
-4.
0.
So it'd be no solution, right?
Exactly.
Oh.
No solution.
Oh yeah, that's right. You can have
I was
zeros.
right, but then I was like, that doesn't look right.
Yeah, it's no solution. So it turns out, ladies and gentlemen, oftentimes you'll get one solution like normal when you have variables on both sides. But if you have variables on both sides of the equation, it's possible that you'll get what?
No solution.
Or what's kind of the opposite of having no solution?
Many solutions.
Infinitely many solutions. Now, how could I change this so that it would be an infinitely many solutions?
0 equals 0.
0 equals 0, right? Or -4 equals -4. Yeah. Question?
I was wondering, whenever you're moving integers from one side of the
Yeah.
equal sign, can you move it one side and then move it back?
Yeah.
Well, in that case, I got an interesting answer. It's probably
But,
wrong.
okay, but yeah, it's just going to increase your chances of making a mistake somewhere. So, if you didn't quite get this, go ahead and fix it real quick. Go ahead and fix it, and then we'll move on to some other examples.
That's nice.
All right, the instructions are still solved. 5p equals 24 minus 3p. Suggestions?
Yes.
Yep. Any ideas?
Are we doing this one together?
Yeah, we're gonna do it together. Just anybody got an idea? Yeah, go ahead.
Can you add 3p to 5p?
I like that idea. Yeah. Most people, when they have to get the terms together, they like to undo the smaller one. And the reason it's a good idea to move the smaller one is that you're gonna end up with positive answers, aren't you?
Mhm.
Positive numbers. You could have moved the 5p by doing what? Subtracting 5p. In which case, what would be left over?
3.
Yeah, 0 would be left over. Alright, so it looks like we've got 8p equals 24. Are we gonna get a nice answer?
Yes.
Oh
We
yeah,
are.
we sure are. By the way, could you check your answer?
Mhm.
Let's try another one. Negative 3/4 times 8n plus 12 is equal to 3, parentheses, n minus 3. Okay, so we got a little more going on, don't we? Yes, sir.
How many examples are we now?
Let's see. Looks like 4, 5 counting this one, sorry. 5 counting. The last one's a word problem, so it may take up a little more space. Alright, suggestions. Distribute. Yeah, distribute first. Let me give you a heads up about what not to do. Some people get it in their heads, oh, I need to get these ends together. Yeah, you do, but they're locked, aren't they? They're locked inside this parentheses. So to fix that, go ahead and distribute. And let's see. I can do this in my head pretty quickly. Can you guys?
No.
So what happens is 8 is actually
It'd be 24 before, right?
8 over 1. So you can multiply straight across.
Negative 24.
You get 24 over 4, right? And then simplify that. Or you can simplify beforehand. How many times does 4 go into 8?
2.
Twice. And then what's 2 times negative 3? Negative 6. Yeah.
So like if we didn't want to do that, we could put it in our calculator at like 0.75.
Yeah, you could. But I don't want decimals as answers. We're going to want fractions as answers. And here's why. I know they're the same thing, right?
Yeah.
But here's why. If somebody writes a decimal answer, they might have rounded it, and I don't know. Whereas with a fraction, guess what? I know that that's the answer. So just a heads up, everybody. No decimal answers. Are you with me? The only time we'll have decimal answers is if the problem started with a decimal. Okay, and I'll remind you of that. All right, next up, we've got negative 3/4 times 12. I'm not going to rewrite this. I'm just going to realize 4 goes into 12 how many times? 3. 3 times negative 3 is 9. And 3n minus 9, right? Let's get the n's together. I'm going to add 6n, add 6n. A lot of people do 2 steps in one line here. If I'm moving the n's to this side, where am I going to end up having to move this?
The other.
Do you want to do that?
Yeah.
Okay. What's left over here? 0. What's left over here? It's 9. A lot of people get to this point and they see that 0 and they go, oh, no solution.
I did it.
Not so.
That's the answer.
The answer is going to be 0. Our answer is 0.
I got it.
Wait,
I got 2.
You got 2?
Yeah.
How'd you get that?
Because I did I put the hold on, hang on.
Oh, I did 6 instead of 9. What's the point of having a variable then if it's 0? You put that in a problem, it's just gonna be like, it doesn't exist.
Okay, scratch my thoughts.
Well, 0.
I screwed up.
0 doubles up as
Oh,
a
wait,
decimal.
no, you like multiply something, I guess.
Yeah, 0 is as valuable an answer as any number, really. Question?
So what I did is I subtracted the 3n from the right side,
Uh-huh.
subtracted 3 from the left side, so I got negative 9n minus 9. And
Uh-huh.
then so I added 9 below, that would make it.
Yeah, 0 over there.
Oh.
Yeah, you should get 0 either way. So if you're not getting 0 either way and you're not sure what you did wrong, let me know. Let me know.
My negative ran away.
Okay, all right. Yeah, common thing is you have a sign that's incorrect.
Yeah.
What do you guys think? Are you prepared to move on?
Wait, no, hold on. I need to.
Are you ready?
You ready?
Wait, so,
Uh-huh.
where did, which way did you? It went the 0 over there, but then.
So I moved the 6n over here. So I knew all my n's would be over here. So I went ahead and added 9 over here
Oh,
to
okay.
get rid of it.
I gotcha.
Let's do another here. 21 minus 7w equals 7 times 3 minus w. Probably you're going to distribute first. You don't have to. You could divide by 7. But then over here, because there's subtraction, you would have to divide both of these by what? If you divide by 7 on one side, you'd have to distribute the dividing by 7 to both sides. That's one way to get this answer. But I think most of you are going to distribute, correct? What do you find out?
21 take away 7w equals 21 take away 7w.
And what's going to happen?
Wait, is that many answers? Many solutions?
Yeah.
Do it.
It's
So
infinite.
you can add 7w both sides, 21.
Yep. So one way to do this is to go ahead and just add the 7w. In which case you find out, oh, that goes well. 21 equals 21. Or you could end up moving the 21s over as well, in which case you would get what?
7w.
Well, but if you got the 7w's together and the 21s together, you would end up with 0 equals 0, wouldn't you? Question, Kylie?
Well, there's a question on the last problem.
Oh, yeah.
So, like, does it matter, like, so on the last problem, on the right side, like, I subtracted the 3, and I got, like, 3, I don't remember where I got to change it. Like, do we have to do it from the left side first?
No,
Doesn't matter. We'll still
doesn't
get the
matter.
answer.
We should get the same
Okay,
answer.
because I would have got 0, I'm pretty sure.
Okay, yeah. No, that's fine. That's fine. Now, here's the thing, ladies and gentlemen. If you get 21 equals 21, or you get 0 equals 0, either way, they match, right? So it's infinitely many solutions.
Can't you just stop when it's 21 minus?
Yeah. Yep, you sure can. Infinitely many solutions. Now, what's interesting is this is also referred to as the identity. And I don't use that phrasing very often. To me, it just makes sense to say infinitely many solutions. But it's also referred to as the identity, which is kind of strange. So do we need to summarize somewhere in our notes the difference between these two, or do you guys have it figured out?
I'm running a guide now.
So the variables drop out. It's either going to be infinitely many solutions or
No solution.
no solution. All right, let's see. I think, yeah, question?
We have 5 minutes until.
Gotcha, yeah. So I think we got time to write down the last question and then probably finish it when we get back. Our last example is a word problem,
Oh, no.
and it tells a little story.
Oh my gosh.
It says Paul bikes
Patty bite.
for 3 hours.
Ugh.
Yeah.
What a dummy.
To reach the corn maze.
He drove that far for a corn maze.
Oh, he rode his bike. Yeah.
That's worse.
That's worse. Yeah.
Exercise.
Alright, he bikes bikes 2 miles per hour.
He's slow.
Wait for it. He bikes 2 miles per hour faster on the way back.
Because he's scared.
Yeah, exactly. His adrenaline's pumping, right? Yeah.
Yeah.
Oh, yeah.
Okay. He bikes 2 miles per hour faster on the way back and only takes 2.5 hours.
Oh, wow. He knocked off the
So here's the question. How fast did Paul bike going to the corn maze? How fast did Paul bike going to the corn maze? So that's what we're gonna figure out.
I feel like if everyone rode a bike and cars never did
Would all everyone's lunch would
Everything would be within like 1 mile. Everything would be smashed together.